We're going to take a look at dividing now in complex numbers. So for dividing, we don't really do division in complex numbers. What we want to do in complex numbers, if we are given one complex number over a second complex number as a fraction, we cannot have an imaginary on the bottom of the fraction. We can't have it as the denominator. So that means that what we need to do is we follow this. So before we go about division, we're going to take a look at what's called the conjugate. So when we're finding the conjugate is just a very fancy word really for change the sign in front of the I. So the conjugate, if I have W here, find the conjugate of W, that is known as W, and we put a little straight line on top of it. That's known as the conjugate. That's the symbol for it. So you can be asked just to find this on its own in a test. The conjugate is just very simply, you change the sign in front of the imaginary part. So it's always in front of the imaginary part that you change the sign. So if you take a little look at the second one, you'll see it said find Z, and it's got the Z with the little line on the top of it. That's the conjugate of Z, and they give us the Z. And again, all we're doing is changing the sign in front of the imaginary part. So Z with the line on the top of it will be a plus I and a plus 4. And again, it doesn't matter the order you write those numbers in, but make sure you change the sign in front of the I. Now what this actually does when we go to graph these kind of numbers is it will give you axial symmetry, so that's mirror symmetry, through the real axis. So that is basically going to flip that W down to the real axis. And again, that won't make much sense now, but when you go to use diagrams and argon diagrams, we'll go back to that again. But that's just where this comes from. Now the method that we're going to use, if you read the very top here, the method that we're going to use when we have something that we need to do division for, is the same kind of technique as rationalizing the denominator from our algebra section in surds. So let's take a look at example 8 then, and we're going to use the rationalized denominator method with the conjugate. So write the following in the form of a plus bi. So as you can see, the problem with this is fractions are fine. The problem is that I can't have an imaginary on the bottom. So the real issue here is this imaginary here, that I value. So what we need to do is we need to get rid of that. Now to get rid of that, what we do is we multiply by the conjugate of it. So that is the conjugate of this, because this is what I want to get rid of, so it's the conjugate of that. So the conjugate of the bottom is going to be 1 minus I. So what I'm going to do here is I'm going to multiply by 1 minus I. Now the reason why is because if I multiply a number by its conjugate, what we end up getting is just a real number. There will be no imaginary part left. So if I multiply this number by the 1 minus I only on the bottom, I'm going to change its value, which is what happens when we are doing the rationalizing the denominator. So to counteract that, what we do is we also multiply by 1 minus I on the top, because what's happening there is we're going to really just multiply by the number 1, because anything over itself is the number 1, which means that we're not changing the value of what this is worth, we're just changing the way it looks to suit us. So again, we're multiplying on the bottom, the conjugate of the bottom, because that will get rid of the imaginaries. We're multiplying by it on the top, because then we're not changing the value, we're technically multiplying by 1. And this goes back to our regular multiplying. It's going to just be the top. There are the two parts on the top and the bottom. Multiplying, you can use boxes for the 2 on the top and the boxes for the 2 on the bottom and put them back together, or you can just multiply them straight out. So I'm going to multiply them straight out, and I'm going to do 2 by the second bracket and minus 3 by the second bracket. So 2 by the second bracket is going to be just 2 minus 2i. Minus 3i by the second bracket will be minus 3i and plus 3i squared. And remember from earlier, our I squared is going to change to be minus 1. On the bottom then, I'm going to multiply the first by the second bracket and then the second part by the second bracket. So 1 by the second bracket will give me 1 minus I. I by the second bracket will give me I and minus I squared. So now to go and tidy this up, what I'm going to do is I'm going to change the I squareds to be minus 1s. So I have 2 minus 2i minus 3i plus 3 times minus 1. All over 1 minus I plus I minus, and a minus 1 goes in for the I squared. Okay, and again, tidying this up a little bit more, the top of it, it'll stay the same, bar the end, plus 3 by minus 1 is going to give me a minus 3. And on the bottom, I'll have 1 minus I plus I, same as before, minus by minus give me a plus 1. And now I can go and I can add the i's with the i's on the top and the numbers with the numbers on the top and do the same on the bottom. So on the top, I'll have 2 take away 3, that's minus 1. Minus 2i minus 3i is going to give me minus 5i. And that goes over 1 plus 1 is 2. And as you can see, minus I and plus I will cancel. And that will always happen if you've multiplied by the conjugate. The i's will always cancel in the middle there and you'll be left with a number. So here's our complex number. Now, if we want to write that in the form of a plus bi, we just split it. So minus 1 over 2 and minus 5 over 2i. Remember that if both of those numbers on the top divided by 2, you could divide it in. However, if one of them divided by 2, you couldn't cancel. So you can't cancel because it needs to divide into both of the things on the top. And that's how we do division.